Tables. So I could give you any limit, but unless I ask for it algebraically, if I ask for it algebraically, you can't do a table, right? But I could give you any limit, and you could technically try with a table. Very, very close to the left of it, very, very close to the right of it. Okay? So say I give you this limit. The limit as x approaches 3, and on the bottom I put x minus 3. Why would I do that? Because that's a problem, right? You're going to have to do something algebraically to get rid of it. But what if I make it that you can't do something algebraically to get rid of it? What do you have to do? Dude. You have to do a table. I'm not even letting you do it algebraically. Did I write algebraically up there? No. So you could do it as a table. Remember the AP questions? Sometimes they just give you a table and ask for the limits. You've seen that on those AP questions that I gave you, right? So they're different. But tomorrow I won't be doing as APE questions. APE? Like money? I don't know. So try and solve it out. Give me a table. Left and right of 3. How do you get close to 3? 2.99999 and 3.000001. Go. So something close to 3 but not exactly at 3. If I put in 2.9, I love when it does that. It's so awesome. I put in 2.9, it gets me 10. It should be on top. Chillax, people. Okay, 2.9. Then we get, looks like negative 10. My blinky blinker is blinking right on the number. Blinky blinkers. And then if I put something closer, like 2.99999. 2.99999. Oh my goodness. It's getting hecka, which is my new word, large. What's going to happen if I do that again? It's getting hecka large, negative, which means it's getting closer and closer to what? So I can say the limit as x approaches 3 from the left of 1 over x minus 3 equals negative infinity. Remember, it's a vertical asymptote. We did this in rationals, correct? You're going to have infinity on opposite sides of an asymptote. It's not a point of discontinuity. Point of discontinuity will reach the same thing, aka removable discontinuity in calculus. But an asymptote, you will have infinities on both sides. Now, guys, I did a ton of research on this because it was driving me crazy because different textbooks give different answers. If it approaches positive infinity on both sides, you can say the limit equals infinity. Indirectly saying that says it does not exist, though. So you can follow behind with the limit as x approaches this equals positive infinity if they both do. But that also means you follow behind with does not exist. So you can state infinity, but infinity means doesn't exist because they don't approach the same number, they approach a concept. And they don't approach it at the same rate. Sometimes they go faster and sometimes the next one's a little slower. So that is why that they can give different answers. Yeah.
What if they do approach it at the same rate? You're 2,000, but that's the same.
It's still infinity. It's still not a number like 100 or a million or 1,000 or something. It has to approach something. So you can still put infinity. Yeah.
Can we just skip playing the infinity part and just write C and E?
No. We shouldn't. We can. But it depends on what prof you have. They might want the infinity part. So it's like I've looked on like all the different places everywhere, and it's very dependent on the person who's talking to you. So I would just do both, and then you cover all the bases of every prof that could possibly come into your. Yes. So this one isn't going to be either of them. Yeah, because it's opposites. Okay. I was just saying, if they do approach, because sometimes they approach positivity, this one is not doing that. Okay. This one does not exist. And then this one, I could do a little further away and go like 3.1, which is quite a bit away. And I get 10. And then I do 3.000001. It's going to be a shock. I know what we're going to get here, but that's okay. Oh, weird. We get a hecka. going to use that all the time. Really large number. Positive. So what are we approaching from the right? Positive infinity. So what is the limit at this? DNE does not exist. It is good to show your work why it doesn't exist, not just does not exist. It's a written response, okay? Because they often have a justify, and if you don't do anything, you didn't justify anything, you have an answer, you get like a 0.5. Very bad. Okay? So that's what we could do. What did we do next? We did graphs, which were the piecewise ones, right? You have those in front of your face. So can you please go flip to that page I gave you yesterday? There's a whole bunch of graphs, right? So we're going to quickly check it here. So this one here, the limit is 2 from the left. It's approaching 3. The limit is 2 from the right. It's approaching 1. And then the limit at 2 does not exist because they don't match. Right? Then we had the limit is 5 from the left. So I go 5 from the left. It's a removable discontinuity, so my limit will exist. Yes? So from the left, it's approaching 2. From the right, it's approaching 2. Therefore, at 5, it approaches 2. And what is the value at actually 5? It is 1. So if I asked you if the graph was continuous or discontinuous there, you would tell me it's not continuous, it's discontinuous, or not continuous, because the limit as x approaches 5 is 2. It doesn't equal f of 5, therefore it can't be continuous, right? Remember, this is the statement I need if I ask you for continuity tomorrow. And by if I ask you, when I ask you, it's not going to be a shock that I'm going to ask you to tell something is continuous or not, right? And how would you prove continuity? You prove that the limit and the value are the same, because it goes from the left, it hits the value, it carries on, right? If a graph is continuous, from the left at the value, from the right, it would just, it goes right through it, correct? If at some point from the left and the right, they're not the same, then it's discontinuous, or from the left and the right, they're the same, but the value's down here, that's not continuous as well, right? So that's how you prove continuity. You have to give me that these equal or they don't equal, and then a statement. Okay, that's what I need. If you choose to not do that tomorrow, you will not get full marks. Do not fight me on it. It will not be full marks. Okay? Limit equals that, or limit doesn't equal, and then a statement. And how do you say the limit doesn't? You have to prove from the left and the right it's the same. Or different. Okay, for 13, we have the limit as x approaches. 1 from the left is 2, and then 1 from the right is 3. Then the limit at 1 doesn't exist. Here we have 5. 5 both approaches 4, so we put 4. And then f of 5 equals 4. So we could actually say it's continuous at x equals 5, correct? And how would we show continuity? We would say the limit as x approaches 5 of f of x equals f of 5. Therefore, the graph is continuous at x equals 5. Not craziness, right? Calculus actually isn't crazy because it makes sense. Like, it should make sense to you. If limit's approaching, value is added, they have to be the same. Approach, go through, keep going, right? Okay. 14, we have the limit as x approaches 0 is 3. From the left of 3, it is 4. From the right of 3, it is 2. Therefore, it doesn't exist. And f of 3 is 3. So this one really doesn't work because the limit doesn't exist. And the moment the limit doesn't exist, this graph can't be continuous, right? But you can still say that the limit and the value are not the same. Therefore, it's not. It's discontinuous at 3. Okay, 15. We have 0 from the left is negative 1. 0 from the right is negative 2. Therefore, at 0, it does not exist. Negative 2 from the, or 2 from the left is 2. 2 from the right is 0. Therefore, the limit doesn't exist. And g of 2 is 1, and the limit as x approaches 4 is 3, because it just goes through. Okay? So this one would be not continuous at 0 and 2, because the limit and the value are the same. Sometimes the value is just an open dot, which is removable discontinuity. So the value of f of 2, let's say, does not exist. This one actually does have a value at 2. It doesn't have a value at 0, though. So f of 0 would be does not exist as well. Now some people say, well, what if the limit doesn't exist and the value doesn't exist? They're equal. they both don't exist. Like, that doesn't matter that they both have the same letters. Okay, that does not mean the graph is continuous. Yeah, no, that. That means from the left it's not the same as from the right, and then there's no value in the middle. It's like the absolute not, like the epitome of a not continuous graph. That's what that would be. Couldn't get a better one. All right. 16. The limit as x approaches 3 is 2, and the limit as x approaches 1 is -1. The limit as x approaches -3 is 1. 2 from the left is 1. 2 from the right is 2. They do not match, so it does not exist. And then this one, we have 0 from the left is -1. It's a really tiny negative sign. 0 from the right is 4. Therefore, at 0 it does not exist, even though that looks like a Z. And then 2 from the left is 1. 2 from the right is 6. And then at 1 is 2.5. Okay? So we did graphs. We explained graphs. Everything was good. Yes? What did we do next? We did direct substitution. So always when you're given a limit, check if you can substitute first. So what does that mean? Sometimes I give you the limit as x approaches 1 of x minus 3 over 2x minus 5, and people start trying to do math. I got to get it to work. No, you don't. There is no problem with plugging in a 1. The graph is continuous at 1, right? So you can directly substitute into there. So I would get 1 minus 3 over 2 times 1 minus 5, which gets me -2 over -3, which is 2/3. So the fact that I can direct substitute tells me the graph's continuous there, because the limits will be the same from both sides, and the value is that because you direct substitute it, right? So in the moment you can direct substitute, it's continuous at that spot. And it's just a coordinate. Oh no, that's the starter pickup. Okay, what do I do after direct substitution? What do I do after direct substitution? Limits algebraically where you can't just plug in. So not direct substitution. And here are some off. Recording it. One like this where I can ask you to do it and then you have to factor. Another one I could ask is one with a radical. 3 minus the square root of x squared plus 5 all over x squared minus 4. What was the other one we did a lot of? Starts with an F. Rhymes with fraction. Rhymes with fraction. Fraction. Fraction one. We did do the F of x plus h. So let's try this one. Limit as x approaches 3, x squared over x over 3 minus 3x over x. Okay, did you guys get your 3 answers? Yes. Did they work out? So we can have polynomials, we could have radicals, we could have rationals. And the rationals that I've given you in the past, go back and practice them as well. I've given you ones where it's 2 fractions over an h, correct? And you still have to make common denominator, flip your 1 over h, and then cancel. Okay, what do we do next? Pardon? Yeah. So we did that Newton's first principle, which gave us the first derivative. So technically, it was f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, which gave us the first derivative, which gave us the tangent slope, and it gave us the general tangent slope, correct? In a longer way. Now, what were the types that I gave you? I gave you 3 types. 1, I would give you f of x equals what? two fractions, not two fractions, it made two fractions. I wasn't that mean. You have 4 fractions along. Yeah, a fraction. So I would give you like 3 over x minus 5. Okay, what else did I give you? Polynomial, and most often I left it as a squared, because if I did a cubed or a 4, you're going to have to expand x plus h 4 times, which is ridiculous. So, especially when polynomials, you'll find out in the week after you come back, if you do power rule, you'll be really mad. So, negative 3x squared plus 6x minus 4. Okay, and what was the third type? A root.
I don't know. I think
Go. So those are the 3 answers you should have, and expect that these would appear. Now, these will appear. If it's a polynomial, it's going to appear in the written response. So those of you who have power rule memorized, sucks to be you. You have to show me the word. Exactly. And then the other one's good luck. If you have chain rule and quotient rule, good on you. Figure it out that way. Doesn't matter to me if it's on a multiple choice.
You have to factor the negative 6 out, the second one. Or can we leave it as negative 6 out?
You'd match them all. If it's a multiple choice, you'd match both. When we get to the next unit, we're going to have to take the negative 6 out because it's going to get us critical numbers. But for right now, either one is fine. All right. Then what did we do?
There's this called average rate.
Average rate of change. If I ask you for that, it's just the what? The slope. Y1, x1, y1, x2, y2. Average rate of change. What else did I give you? Intermediate value theorem. What was that?
If you have a value below the x and one above the x, then it's continuous. It has to have an x-intercept somewhere.
Or values in between it. So, for example, if I gave you, guys, you should be paying attention. If I gave you the intermediate value theorem and I gave you, say, 2 to 4, that is actually the domain, correct? So this would be an x, this would be an x. So I can give you a polynomial and you'd have to find out what the y values are for that, correct? If I found the y values, I found f of 2 equals negative 4, and I found f of 4 equals 7, and it was a polynomial function, what would you have to tell me? Why?
Because polynomial functions are continuous.
So you have to say that the left endpoint is at negative 4, the right endpoint is at 7, and because it's a polynomial function, it's continuous between negative 4 and 7. Therefore, at some point, it's going to have to cross through the x-axis, and there will be a root. Correct? The other thing it could be is it could be any y value between what?
Negative 4 and 7.
Negative 4 and 7. So instead of asking for a root, I could ask if the y value 3 exists on this graph.
Yes.
And you would say yes. Why? Because negative 4 is below 3, 7 is above 3, those are my endpoints, it's a polynomial function, it's continuous. Even if it was a rational function, it could be continuous between 2 and 4 as long as the asymptote doesn't fall in there, right? So it doesn't have to be a fully continuous function in order for the intermediate value theorem to work. It just has to be continuous between the interval of domain that I give you. Okay? So you have to say continuity and find the endpoints. What else did we do?
Continuity.
We had squeeze theorem. There's going to be one of the ones from the thing that they start with an S and rhyme with sign. Okay, and then, all right. The other thing that we did was trig limits, yes? So what if I give you this one? Determine the limit as x approaches 0 of sine 7x over 5x. Do not just give me an answer without any work shown. I will be unimpressed. And you will not get full marks. There's that one. And the limit as x approaches 0. What was the other one I wrote down? 7 minus 7 cos x over x. Our rules are this. Remember, if we had, if we can get into this form, the limit as x approaches 0, of sine x over x, what does that turn to? A 1. Anytime we can get it, if it was sine 5x over 5x, a 1. Sine 8x over 8x, a 1. Correct? The other one was the limit as x approached 0 of 1 minus cos x over x. That becomes a what? A 0. Right? That was the rule. So for this one, I have sine 7x over 5x. Well, I need it to be over 7x, correct? And other times I've given you sine 7x over sine 5x. Then you have to times the top, whole, make it a fraction, times by 7x over 7x, and the bottom by 5x over 5x. We had to do that, correct? But this one only has a sign on the top. So I'm going to rewrite my limit. And now I have sine 7x over 1 technically. And I need to multiply it by 7x over 7x. So I get that 7x in the denominator. And then the 5x just sits on the bottom because it doesn't have a sign. If it was sine 5x, I'd have to multiply it by 5x over 5x. It is not. Okay, so the 7x can transfer over to here, correct? So I can technically put the 7x in the bottom and get rid of it here. And what is sine 7x over 7x? If it has to approach 0, what's that going to become? 1. So I get 1 times 7x. So in my next step, I have the limit as x approaches 0 of 7x over 5x. The x's cancel, my problems are gone, and my answer is 7 over 5. And then the limit drops off because I'm done. Now I need it to be, the next one, I need it to be 1 minus cos x in order for me to use the formula. So what can I take out? What?
Isn't it cos x minus 1 over, I see it.
I need it to be cos x minus 1. Is it cos x minus 1 right? Oh, this is wrong way.
Oh, yeah.
Sorry. I need it to be cos x minus 1. It is not. What do I have to do? That was a right O on the top. I have to take out a what? Not a 7, a negative 7. So I'm left with negative 1 plus cos x over x. And if you want, you can show that, like this is multiplication, right? So I could actually split it. I could go to the limit as x approaches 0. This negative 7 is a coefficient, correct? I could take a coefficient completely out of the limit. We talked about that with limit law, so I can do this as well. And then I get negative 1 plus cos x over x, which turns to 0. Or I could go 7 times 0. It's still 0. So that whole thing's going to, so we're going to end up getting negative 7 times 0, which is 0. The last thing we talked about was continuity, but we've kind of talked about continuity a whole bunch already, right? And you have to be able to graph a piecewise function. We've done that numerous times, yes? We have to be able to graph piecewise functions. We have to be able to talk about where a piecewise function is continuous or not continuous, right? All of those things are fair game, right? Where we talked about piecewise functions, graph a piecewise function, continuity is the limit as x approaches whatever c value, and then they exist. So remember, whenever I ask for continuity, the limit as x approaches c, let's say of f of x, has to equal what? F of what? C. That's for continuity, correct? And for it to not be continuous, doesn't equal. So the only thing we haven't done is limits to infinity, where we like use x approaches infinity instead of like 1 or negative 1 or a value like that. But we're doing that on Friday, so that won't be on this test, because I thought this was enough things. So remember, intermediate value theorem, and average value can be on there as well. Average value is just slope. So you need to get the x2, or x1, y1, x2, y2, and find the slope of it. That's what the average value is. It's in your notes. Go look at an example. There is.
You just, is that the
Yep.
whole question?
Yeah.
Oh.
So if it's the average value of a function, find the slope. But just go look in your notes. There's an example on it. I think it's the very top example, third lesson in. No. rise over run. So in order to rise, which way are we going? Yeah, y2 minus y1 over x2 minus x1. If you flipped them anyways, Eric, as long as you put the same x and the same y first, it doesn't matter.